Now that we have seen the linear polynomial y is equal to kx, which has its own graphical properties passing through origin. Now let's see one example problem to understand the concept more stronger. Imagine I have a line y is equal to 3x, or I take y is equal to 2x. And my question out here is to sketch y is equal to 2x on the Cartesian plane. So let's see how this linear equation in two variables x and y with its special case looks in the Cartesian plane. Now, as we know that the given equation is y is equal to 2x, where the constant c is missing, it's clearly in the form y is equal to ax plus b, where b is 0. I mean ax plus c or ax plus b, where the constant is 0. Therefore, this line must pass through origin in the form y equals kx. So this line passes through origin is how I understand the concept of the given example problem y equals 2x, a linear equation in two variables x and y without the constant as a special case. Now, in order that I sketch this, the first thing which I take into the rule is about the table of values. Now, as we know that to sketch the line or to make a line, it is minimum of the 2 points which are required. So, if I have 2 points which can be identified for this line, which lie on this line, then it's easy to sketch the line. The minimum conditions for a line are 2 points. My first row with variable x and my second row with variable y. When x is 0, my y is also 0, because when x is 0, my y is 2 times of x, which is 2 times 0, and this is 0. Therefore, when x is 0, the y coordinate substitutes to get the value 0. Similarly, if I take another value, say 2, when x is 2, my y is 2 times of x, that is 2 times of this 2, which is 4. Therefore, when x is 2, my y is 4, is how I understand the sketching concept through the table of values. Now that for 2 points I have got one of the point as represented by the second column and the other point represented by the third column, I clearly understand that there are 2 points P which is 0, 0 and the points Q which is 2, 4. That is the points P 0, 0, that is the origin, and the point Q which is 2, 4 pass through the given line y equals 2x. So let's see how we can sketch utilizing these two coordinates as evaluated through the table of values. Now that we have evaluated the values of P and Q which lie on the line y equals 2x, let's see how we can sketch the line utilizing these two coordinates on the Cartesian plane. So initially, I'm going to start with sketching of the Cartesian plane. Cartesian plane with x-axis and y-axis. The horizontal axis, which is x-axis, and the vertical axis, which is y-axis, and the point of intersection, which is the origin. Clearly, let me first make a scale of 1 centimeter equals 1 unit on x-axis. So here is 1, here is 2, here's 3, here's 4, 5, 6, and etc., so on and so forth. And on the left I have -1, -2, -3, and -4. Similarly, I take a scale of 1 centimeter equal to 1 unit even on the vertical axis, that is the y-axis. 1, 2, 3, 4, 5, and similarly the values on the negative side of the y-axis being -1, -2, -3, -4, and so on and so forth. So with this scale of 1 centimeter equals 1 unit on x-axis, and equally the 1 centimeter equal to 1 unit also on the y-axis, let's see how we can sketch the points. Starting with point P. The point P is origin, that is the initial point 0, 0. Therefore, I see that this point clearly is the origin which is fixed here. So my point P is out here. Coming to the next point, point Q is 2, 4. That is, the point moves 2 units to the right from the initial point, 2 units to the right from initial point, and 4 units up from there. Therefore, once I reach 2 units to the right from its initial position, I jump 4 units to the top. Is how I get the point Q, which is 2, 4. Is how we get the point Q and point P in the Cartesian plane. Now, as we know that to draw the line, minimum 2 points are essential. Now that we have got the points P and Q in the Cartesian plane, it's about sketching the line. Sketching the line is about joining the 2 points and extending the line on the either side. So here I just join P and Q and extend in this manner. So I get this to be a line which is extended on the either side and equally passing through P and passing through Q, both the points as obtained through the line y equal to 2x. Therefore, the line as obtained passing through P and Q clearly is witnessed to have been passing through origin. So what do we make the learning outcome? The biggest outcome here is that if the line y equal to 2x is expressed in the form y equal to kx, then that line must pass through origin. Therefore, a line y equal to 2x with the points 0, 0 and 2, 4 as picked and on random choice are just located on the Cartesian plane here and here, and when a ruler is taken and you draw a line, it passes through P and Q and we obtain this line. And this line, as it is represented by the arrows, is nothing but the line y equals 2x. And importantly, this line expressed in the form y equal to kx passes through origin. It must pass through origin because it does not have a constant. No constant must pass through origin. A constant, then the line does not pass through origin. So a constant plays a vital role in deciding whether the line passes through origin or does not pass through origin. Y equals 2x passes through origin is the learning outcome in this problem. A, y equals ax plus b does not pass through origin if b is not equal to 0. The condition is this line does not pass through origin if b is not equal to 0. If b is equal to 0, then this reduces to the form y equal to kx or y equal to bx, and the line must surely pass through the origin. B, the constant, decides the factor for the line passing through origin and not passing through origin, as seen through the example problem y equal to 2x.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.